12.1 Triangle Proportionality Theorem. Please do the construction activity over here, guys. And pause the video. When you're ready, start to play again. Okay. So the first step is asking to draw a triangle ABC, which I gave to you already. And select the point on AB, any random point. I'll just try to point, let's say this one right there, okay? And it says to construct an angle E, vertex E, that is congruent to an angle B. So I need to copy this angle at this point E, okay? And knowing that if the angle is the same, I see that it will be parallel to each other, right? So what you can do over here, guys, is generally what I like to do, oops, that's just too big, make it a little smaller. Yeah, that's gonna work better, okay? So what I do is create an arc this way, and do the same thing with this one, like this. And what I do is come this way to measure the same length. As it turns out, that's not exactly the same, so let me just move it just a tiny bit. Okay, see that right there, guys? And then I do the same thing from here, right there, and I will connect those 2 points, this point right here and this point. And when you connect them, these 2 lines should be parallel. Okay. So the reason why they're parallel, why? Because if this angle and this angle is the same, because if corresponding angles are congruent, then lines cut by a transversal are parallel. Okay. And what we're going to do is we're going to use a ruler to figure out the ratios of the fractions, guys. So we're going to measure AE, EB, and then I guess we will label this F right here, right? And find the length AF and FC. Let's do that. I'm going to use the millimeters here, guys. This will be I could see it's about 1.1, and that right there is 1.8, and that right there is 1.8, and right here is 2.9 is the closest that I can read it. My eyes are not as good as it used to be. Alright, so I'm going to copy it over to this right here, guys. So that will be 1.1 millimeters. EB is 1.8 millimeters. AF is 1.8 millimeters. And FC is 2.9 millimeters. According to this, AE over EB is 1.1 over 1.8, and this will be 1.8 over 2.9. And let's put that in a calculator and to see what the value is. Okay, they're very, very close. So this is 0.61 and this is 0.62. Yeah, so considering that I've eyeballed it, and okay, so do you have any idea what we could do to maybe perhaps make this line more parallel, more accurate? One of the ways to do that is make this arc bigger, right? The longer the arc over here, more accurate it is, but there's a limit to that because of where I chose the points. And also, there's also a mistake in the measurement, in that maybe I wasn't seeing all that carefully as well, because I did to the nearest tenth. I'm sure it wasn't exactly 1.1. It could have been a little bit off from that. Okay, so there's a lot of little things, but all things considered, this is actually a pretty accurate measurement. Okay. So triangle proportionality theorem says if a line parallel to a side to a triangle intersects the other two sides, then it divides those sides proportionally. So what that literally means is that ratio of this to this is equal to this to this. Okay, so that could be AE to AF is equal to EB to FC, or you could say AE over EB is equal to AF over FC. If you're not sure if this is true, if you cross multiply both of them, the result will be the same. When you cross multiply, it's AE times FC, just like this one. And here, it'll be AF times EB, and it'll be EB times AF. The order in which it multiplies is different, but it's actually the same thing. And that's one of the ways for you to actually figure out if this is in fact true. Okay. All right, guys. So in this particular case, we're doing the proof of the triangle proportionality theorem. Actually, this has been swapped. And how would you prove that? Let me do this by paragraph proof, guys. So if these two are parallel, right? So if these two lines are parallel, we know that this triangle and this triangles are congruent, and we know that this triangle and this this angle and this angle is congruent. Therefore, by using corresponding angle theorem, we know that these two angles are the same. So we know that the angle AEF is congruent to angle B, and angle AFE is congruent to angle C. That means that triangle AEF is similar to ABC by angle-angle similarity triangle theorem. Now, once you do that, I suppose we could do this fairly quickly. We're just going to label this, guys. Let's call this X. Let's call that Y. And let's call this P. And from here to here, let's call that Q. Okay? So according to the similar triangle theorem, and the definition that is, the corresponding sides are congruent, which means that we have this to this. You know what? Because we're looking for EB, let's call this P and let's call this Q. That will make this slightly easier to do. So we have to now just know that this to the whole length, x over x plus p, is equal to y over y plus q, right? And we need to somehow show, according to this right here, guys, AE over EB, and that's equal to x over p is equal to y over q, right? So we have to go from here to here. And why don't you pause the video to see if you could figure that out for it. Okay, so if you tried it, you know that we learned earlier that we could just change diagonally the locations, right? Or you could flip both fractions upside down. If you do that, this turns out to be x plus p over x, y plus q over y, and that turns out to be, if you divide through by x, would be 1 plus p over x is equal to 1 plus q over y. Subtracting 1 from both sides, we get p over x is equal to q over y. And if you flip it over again, that's what we get right there. Therefore, we know that the AE is EB and AF is FC. Once again, I just prefer to use a letter here because it's quicker to write and easy to see than AE and EB writing that out. Okay, guys. So we got examples 4 and 8 from your book. So find the length of xz, and this is the question mark right there, right? And using the formula, we know that it's xy over 18, xz over zv, which is 30, but we know that xy over here is 12, because if the entire length is 30, and from the part of it is 18, the remainder must be 12. So I'm going to replace that with 12 here, guys. Right? And then before I multiply, I can actually reduce this. That's equal to 2/3, is it not? Right. So when you cross and multiply, it's equal to 60. We could see that xz is equal to 20. Okay. Yeah, so that was a nice, easy way of doing it. And then example 8 from your book, I believe, what are we looking for? Verify that WS and they're parallel. Well, according to the proportionality theorem, we could say that if the ratio between these two is the same, then it must be they must be parallel, right? Okay, so you got 1.5 divided by 2.5 is 2.1 over 3.5. All right, that turns out to be 3/5, and that turns out to be 3/5. That implies that FW over WD is equal to FX over XE. So we can say since FW over WD is equal to FX over XE, by the converse of triangle proportionality theorem, WX is parallel to DE. Yes, I do realize that we actually didn't do a proof of converse of proportionality theorem, but it's a little quirky with this book, so let's go with that, okay? So move on to your turn. You got examples 5, 6, and 9. And once you're done, you should get started on homework 54. Pause the video and I'll go through the solution with you guys. Okay, let's go through the answers for the your turn. We're looking to see what the length over here is, guys. So we need to sort of see, oh, it's parallel over here, guys, which means that this triangle and this triangle is similar. And as we learn, that ratio to this and this to this has to be the same. And then, so 32 over 24 is equal to 40 over dg. And doing some math, I'm not going to show that step in the middle. The answer turns out to be 30. But for quiz and homework, you should show the step in the middle. And same thing over here, guys. So this is the part that we're looking for. So we know that the, I wrote it a little bit differently. Normally, I would write 10 over Rn is equal to 8 over 5. But you could actually go 8 over 10 is 5 over Rn. So either one is okay. And it turns out to be Rn is 50 over 8 or 6.25. Number 9, we need to verify this. So we just need to make sure that these, the ratio of these two and these two equal to each other. And when I did that, 90 over 72 equal to 5/4, and 67.5 over 54 is 5/4. So we just showed, because VT over TR is equal to VU over US, so by converse of triangle proportionality theorem, TU must be parallel to RS. Okay, guys, please go ahead and start your homework on 54.